Hello class, for part 6, we're going to look at something that's called resistivity. Last time you learned that objects, especially electrical objects, have something that's called resistance. And resistance is an object's resistance to the flow of current. If there is a lot of resistance, then there will be not a lot of current flowing. If there is low resistance, then there will be a lot of current flowing. Now there are some factors that affect the resistance. Today we're going to look at wires. Some wires have more resistance than others, and what are the factors that affect the resistance of these wires? There are actually 3 factors: the length of the wire, the thickness of the wire, or otherwise known as the cross-sectional area of the wire. So what do I mean by cross-sectional area? So if this is the wire, it's this face here or this area here. This is the cross-sectional area. So this is a big cross-sectional area, and this is a wire with small cross-sectional area. So this first wire is thicker. So a thicker wire has big cross-sectional area, and a thinner wire has a small cross-sectional area. And also, the material of wire will affect the resistance of the wire. We can calculate the resistance of the material using these 3 factors here. So as you can see, here is another formula for resistance that you have to remember, is equal to the resistivity, the length, and also the cross-sectional area. And let's explore these 3 factors and how they affect the resistance of the wire. Let's look at area first. And here I have a wire. So basically, if a wire has a larger area, what that does is it will decrease the resistance. Okay, and the reason for that is if the wire is thicker, that allows more current and more charges to flow through the wire. And because it allows more current to flow, that means it has less resistance. As you can see here, from the formula itself, if you make the number, the denominator of this fraction bigger, then that will make the resistance smaller. And if you go the opposite way, if a wire is thinner, that means it has a small cross-sectional area, that will make the resistance bigger. Okay, that's because a thinner wire is very hard for the current to flow through because it's very thin. There's not a lot of space for the current to flow through, so it's very tight. Now let's look at the length. If you increase the length, if a wire is longer, that will increase the resistance. But if you decrease the length, if the wire is shorter, then the resistance will be smaller. This is because a shorter wire very easy for the current to pass through because the current only has to pass through a short distance of the wire. Whereas a longer wire, then the current will have to go through a long distance of the wire. Therefore, there will be a lot more resistance. Now, resistivity is something that I'll explain very soon, but let's look at how it affects the resistance. If an object has more resistivity, or a higher resistivity, then the resistance will be higher. If an object has a low resistivity, that means the resistance will be lower. So from this formula, you can also tell that the resistance is proportional to the resistivity. So that means if you double the resistivity, you will double the resistance. If you triple the resistivity, the resistance would also be triple. So this is what we mean by directly proportional. And also the opposite is also true. If you halve the resistivity, the resistance would be half as well. From this formula, you can also tell that the resistance is proportional to the length. So that means if you double the length, you will double the resistance. If you triple the length, you will triple the resistance. If you halve the length, you will halve the resistance. Whatever you do to the length, the same thing will happen to the resistance as well. However, in the case for the cross-sectional area or the thickness, the resistance is inversely proportional to the area. So that means if you double the area, you will halve the resistance. So it has the opposite effect. If you triple the area, you will cause the resistance to decrease by 1/3. If you halve the area, or if the area decrease, then you will actually double the resistance. Now let's talk about resistivity. What is resistivity? It tells us how much that object allows current to flow. A material that has a high resistivity means that it has a high resistance and therefore it does not conduct electricity well. Whereas a material that has low resistivity means that it has a low resistance and therefore is a good conductor of electricity. So conductors typically have low resistivity, whereas insulators typically have high resistivity. Now, resistivity has a unit, and that unit is ohms meter. Here are some examples of several materials and their resistivity. So, as you can see, for conductors, their resistivity is quite low. So, silver, copper, tungsten, iron, constantan, nichrome, and graphite, these are conductors. And you can see their resistivity is very low. It's times 10 to the power minus 8. So that's 0.0000000016 for silver. And polythene, which is an insulator, it's a type of plastic. It has a very high resistivity. So that's 10 to the power of 16. So that's 1 with 16 zeros after it. So that's very high resistivity. So it's an insulator. So like I said, polythene has high resistivity, so it's a poor conductor of electricity, otherwise known as an insulator. Copper is one of the best conductors of electricity due to its low resistivity. This is why connecting wires are usually made out of copper. Silver is even better than copper, but we do not use silver in our wiring because it is quite expensive. That's why we commonly use copper in our wires. Metals that have high resistivity can get hot and glow if a current is passed through them. Therefore, it has its uses. So nichrome is used as heating coil in kettles. Tungsten is used in filament lamps and so on. So we will look at these two in the next two chapters. So talking about resistivity and the length of wires, we can now talk about how variable resistors work. So you remember there are two types of resistors. One is a fixed resistor that you learned in the previous lesson, and this is the variable resistor. Variable resistors are resistors where we can change or vary the resistance, so you can increase or decrease the resistance. They are also known as rheostats. Now there are a lot of different types of variable resistors. This is the old version and this is the new version. So rheostats or variable resistors use the ideas that longer conductors or longer wires will have higher resistance than shorter wires. So this is the wire round rheostat or wire round variable resistor. As you can see in this resistor, you have a long piece of wire that is coiled around this metal rod here. So it's coiled around, okay, like that. So how does it work? You can read through all of this and also this one here, but I'll try to explain it in a much more simpler terms for you. All right, so I'll use this diagram to explain how this works. Okay, so basically you connect the wires here at this point here and at this point here. So the wire will go through this point and then will follow the coil of wires here, and then it will stop wherever the slider is, go up and go up this other rod and exit through this other point here. So what you do is you change the position of the slider in order to control the resistance. If we want the variable resistor to have a low resistance, you move this slider here, which is this thing here. You move it to the left or here, in other words. And what that does is it will cause the current to flow for only a short amount of distance. So the current will flow through here and up until where the slider is, and then it will go through this other rod and exit the variable resistor. So in this case, because the wire that the current passes through is shorter, then this variable resistor gives low resistance. So as you know, short wire gives a low resistance, so more current will flow. And if you want the variable resistor to give a higher resistance, you move this slider further to the right. So the slider will be here. So what this does is when the current flows through this variable resistor, it will have to travel a long coil of wire. So the wires are longer up until it reaches the slider, and then it goes up and goes out through this other point here. So because the wire is longer in this case, the current has to flow through a longer distance of wire. This variable resistor gives a high resistance, and when there is a high resistance, there is a low amount of current flowing through this resistor. So that's how the variable resistor works. By moving the slider, you can change the length of wire in this variable resistor, and therefore you can change the amount of resistance this variable resistor gives to the circuit. Now, variable resistors have this sort of symbol here. Okay, so there are two types. You can use either one. So like I said, a rheostat can vary its resistance. If connected in a circuit, it can use to vary current. When the resistance of the rheostat is low, there will be more current flowing in the circuit, and it is also true in the opposite case, and also vice versa. Now, we can use the rheostat or variable resistor to control the current in electric circuits. Here are some examples. Fans have motors that move faster when there's more current. The larger the current, the faster the fan's motor rotate. By using a variable resistor, we can vary the current and hence control the speed of the fan. Light dimmers also are rheostats. So these lamps glow brighter if there is more current. A rheostat can be used to vary the current and hence vary the brightness of lamps. So to summarize, we looked at the factors that affect the resistance of a wire. Make sure you remember that. So we also looked at resistivity. If there's more resistivity, the resistance will be more. If there's less resistivity, the resistance will be less. We also looked at length of the wire and how that affects the resistance. If it's longer, there will be high resistance. If it's shorter, there will be low resistance. And we looked at the thickness of the wire, or otherwise known as its cross-sectional area. If the cross-sectional area is bigger, that means the resistance is lower. And if the cross-sectional area is lower, that will cause the resistance to be bigger. Make sure you know how to draw the symbol for a variable resistor. So it looks like this. This is how I usually draw it. Or you can draw it the other case. You have an arrow pointing downwards like that. And make sure you know what is the function of a variable resistor. It changes its resistance in order for us to control current. For part 6, we're going to look at something that's called Ohm's law.